Although we are quite comfortable and accustomed to looking at the functionality of computer networks in terms of layers, but in real world, layers do not exist. As a matter of fact, all these layers are working at the same time. That is why, in certain situations, cross-layer contentions do arise. In this module, we shall look at the behavior of transmission control protocol in response to an error that occurs due to bit error rate at the data link layer. For that, we shall look at a reference topology. We shall explore the paradox that causes TCP to malfunction, and we'd look at the simulation support which is available in Mixim. In order to fully understand why TCP is not very successful on wireless links, you are referred to the first two papers, TCP performance issues over wireless links and TCP in wireless environments, problems and solutions. And then the third paper, simulating wireless and mobile networks in OmNet++, where the Mixim vision allows you to implement the behavior of TCP in the presence of bit error rate. The reference topology is such that we have on the left hand side a fixed host, also called the correspondent node, which is connected to a router through a point-to-point wired link. The router is also acting as a wireless base station for wireless nodes on the wireless network, as you can see on the right hand side. Now imagine a scenario in which a mobile host is a driver driving in a vehicle connected to the internet. That user is, let's say, downloading or uploading a file from a remote server. In such case, the driver is the mobile host and the server is the correspondent node. The traffic that is leaving the server in the wired domain is entering into the wireless domain. TCP is an end-to-end protocol. So TCP has to take care of congestion and flow control issues end-to-end. But interestingly, when TCP was initially designed, it never took into consideration the behavior of the wireless links because it was meant for wired links to begin with. The figure below shows you that if you have the topology such that we have node S, A and B, and there is a small obstruction between S and B, and there is no obstruction between S and A, this is going to result into signal degradation. The signal degradation in turn affects the delivery, the goodput of the transmission, causing errors. And that is why we see errors occurring and taking place in wireless environments. Now, let's explore the paradox or the situation that is tricky to deal with. TCP, as we understand, is for congestion control. The packet loss due to physical layer, that is channel behavior, causes bit error rate. The bit error rate is represented usually in terms of 10 notation. For example, 10 to the power minus 6, it means 1 bit in 1 million bits is in error. Or 10 to the power minus 9, that is 1 bit in 1 billion bits is in error. But TCP does not know anything about that. So if a packet is lost or discarded at the receiver just because there was 1 bit in error, not because there was congestion on the network, TCP enters into slow start because it finds that the acknowledgement has not arrived. This wrong interpretation causes severe starvation for wired cum wireless links. The line of sight effect, as I mentioned before, causes the transmission between S and B to become weaker and hence causing the errors to occur. With the basic support of TCP IP in INET, there is also a support for data link layer and the physical layer in Mixim. In Mixim, they have provided a decider module. Decider module is a classifier that classifies, or in other words, identifies incoming messages into either receivable messages or mere noise. If the messages are receivable, it means the messages are coming. But are all these messages intact? Then decider determines the number of errors, if at all, in each message. If a message is corrupted, it could either be processed using forward error correction, or, as it happens in TCP generally, the packet is discarded and a retransmission is expected after the timeout. The decider module also provides information about the current state of the channel, represented through bit error rate and packet error rate. The physical layer class graph for Mixim is shown in here. On the left center, you can see the decider module. It takes frames from the air, from wireless interface, and it determines if it is a valid signal, that is a message, or mere noise. And on the basis of it, it carries out other processes.